Good morning, everyone. Today we're going to talk about gravitational fields and how to calculate them for planets, specifically planets in our solar system. So what we need in order to calculate gravitational field is we need a couple of things. Let's start first with Newton's laws of universal gravity. So that's going to be G m m over r squared. Oops, it's going to be a little bit too high. Let me just shift that down there. Here we go. So G being the gravitational constant of the universe, m, we're going to call this the active mass and this the passive mass. The active mass is the mass that we are generating the force from. The passive mass is the object that is sitting inside the gravitational field. And r is the distance between this object and that object. Okay? So to calculate gravitational field, what we're going to do is we're going to ignore the passive mass and only concentrate on the active mass. So for gravitational field, the equation turns out to be, and I should be careful, this should say force gravity, okay? For the gravitational field, we're going to use little g, and there is a reason for that. And that little g is going to be equal to the gravitational constant again, g, the mass of active, the object that is pulling, divided by the distance in between. Now, because we've eliminated the passive mass, what we kind of have to do is create a new sort of passive mass, and it's called a point mass. So imagine, if you will, we have a planet, and we'll call this planet Earth, and I'm going to do that right below here. Here is my planet Earth, okay? And I've only got part of it in the screen, but that should be more than enough. The Earth is doing the pulling on my object, so this object, the Earth, is going to be my active mass. Okay, so this is the Earth, and because we are concerned about this object generating a force on another object, that is why it's called the active mass. The distance in between is referring to the location from the center of the Earth to where I want to measure the gravitational field. Now that could be the surface of the Earth, that could be above the surface of the Earth, that could be where the moon is located, but it's going to be the location of where I want to measure that gravitational field at. Now, we're going to do the surface of the Earth because we want to do it with respect to ourselves, so we're going to check this point. Now, we are going to create a point mass, and a point mass is just a placeholder. It just tells me where I'm going to create this measurement. So I am going to create a point mass, and that point mass is going to be at that point, so that I know r squared is the distance from the center of the Earth to that point mass. Okay, so this becomes r. Okay. Now, in order to solve this problem, we just need to now plug in some variables. So to calculate my gravitational field, I'm going to need the gravitational constant, which is 6.67 times 10 to the negative 11. That's my gravitational constant, the mass of the Earth. Boy, I got to remember this one. I think it's 5.64 times 10 to the 24, divided by the radius of the Earth. And the radius of the Earth, boy, I keep forgetting this one. I think it's 10 to the 6th. I think it's, if I'm not mistaken, I think it's approximately 6 times 10 to the 6th. I think that may be, yeah, I think that could be correct. I'm not exactly sure. There's something that, oh, okay. That tells me that, yeah, I think I'm pretty good on that. And that, remember, is squared, okay? So doing some quick math here, I have a 10 to the 6 squared. So that is going to be the equivalent of 6 squared times 10 to the 6 times 2. That's me bringing the square into it. So and the reason why I'm doing this is because I want to deal with the exponentials first. So 6.67 times 10 to the, oh, that should be times 10 to the negative 11, times 10 to the negative 11 times 5.64 times 10 to the 24. And that's going to be divided by 36 times 10 to the 12. So these two will combine. Oh, barely can see it, so let me move it up. These two will combine, Okay, I've got to the negative 11th and the negative 12th, which will give me a to the negative 24. So if I were to go just a little bit lower on this, I would end up with 6.67 times 10 to the, and I'm just combining the powers of 10 here, to the negative, that'd be negative 12 to negative 11, which is going to give me to the negative 23rd, times 5.64 times 10 to the negative 24, all of that divided by 36. Okay? Well, to the negative 23rd and to the negative 24, these will cancel and just give me to the 10 to the 1, or times 10. And at this point, I'm just doing some simple calculations. Okay? I got a 56.4, which is where that 10 is. I've got this multiplied and I've divided by this. I can do some things like take this out and take that out and say that's approximately 6. But at this point, I'm just simply calculating the final end product of it. Now, if I were to want to calculate another planet, so let's take, for example, Mercury, all I would have to do is replace this, which is, nope, sorry, not that. Replace this, which is the mass of the Earth, and replace this, which is the radius of the planet. So if I were to use Mercury, I'd want to use the mass of Mercury and the radius of Mercury, and that would give me the gravitational field at the surface of Mercury. The other thing I would do is, let's say if I wanted to calculate, let's say the orbital space station, which is more like down here and not necessarily up there, I would just simply take the radius of the Earth and add that additional distance to it and then square it to be able to calculate what that gravitational field is at that point. I hope this makes sense, but this is the lesson for today on how to calculate gravitational fields.